Unit 7, Learning Target number 6. Find the area of polygons using simple shapes. Okay, now our job is to find the area of polygons. Now a polygon, if you think about it, a polygon is anything that has many angles. That's what polygon means, many angles. Now a square is a polygon. A triangle is a polygon. Anything that has more than 2 angles is a polygon. But when we're talking about polygons, we're thinking of something that has lots of angles. Like this one has 1, 2, 3, 4, 5, 6. 6 different angles. 1, 2, 3, 4, 5, 6 different angles. And that's normally what people are talking about. It's easy to find the area for things like squares and triangles because we have formulas to do that. These kinds of shapes, these more complicated shapes, give us a little bit more difficulty. But the good news is it's still pretty easy if you know a little trick. So Nate wants to replace the felt on his pool table shown here. The felt is this green stuff. Help him find the area of the tabletop. He needs to know the area so he'll know how much felt to buy. Now, what makes it hard to find the area of this shape? Well, obviously, it's not a square. It's not a rectangle. It's not a triangle. It's not a trapezoid. It's not a parallelogram. We don't have any formulas for finding this particular shape. So let's try a different tack. Let's try this. Can we find simpler shapes in this figure? Can we find any simple shapes that we could find the area for, that we do have formulas for? Can you find any? Let's look here. Now, if I was to take this line and extend it out like this, boom, 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 boom. If I was to extend that out like that, I now have 2 simple shapes. I have a square right here, kind of. I have a rectangle right here. Okay? It's not really a square, it's a rectangle, even though it looks like a square. I have a square that is 2 feet on this side and 3 feet on this side. 2 feet on this side and 3 feet on this side. I also have a rectangle that is 5 feet on this side, 3 feet on this side, 5 feet on this side, and 3 feet on this side. So I have 2 very simple shapes. So, moving on to the next step, we can find the area of this whole thing. We can find the area of this entire shape right here, this whole thing, simply by adding the areas of the simpler shapes. So we can take the area of this guy and add it to the area of this guy, and that will give us the area of the total shape. So let's try that. First of all, we remember that the formula for area of a square, or a rectangle rather, is length times width. So length times width, and we get 2 times 3, which is 6. And over here, we remember the same thing, length times width, which gives us 3 times 5, which means 15. So 15 and 6. Now we simply add those areas together. 15 plus 6 gives me 21, and that gives me 21 feet squared for my area. And remember, all I did was divide it up into simpler shapes, find the area of each shape, and then add them together, and that is called decomposing. Lorna wants to buy this sofa, but she isn't sure if it will fit in her living room. Help her find out how much space it will take. Now, look at this shape. Again, we've got a polygon here. It's all kind of strangely shaped. We've brought it down here to look like this. This time we're going to use what's called composing this figure. We're going to compose it into a larger figure and see how that helps us. So it's just another way to solve a problem. Now, can we see a larger, simple shape that this complex shape will fit into? In other words, can we find a shape that will kind of encompass this one, take this one and place this one into a simpler shape? Well, hopefully you can. Hopefully you can see that this will fit into a rectangle shape. Here we have a rectangle that goes all the way around like this. We could fit this into a simple little rectangle. Now the benefit of that is I know how to find the area of a rectangle. It's very easy, remember, it's length times width. And so I could find the area of this whole shape, and then what I can do is I can subtract the smaller shape here, and then I'll have my total. So what we'll do is we'll find the area of the whole thing and then subtract the area of this little space. That way we have just the area of this, and we can do that by composing these shapes. So let's do that really quickly. We know that the area of the whole rectangle is found by length times width. And length times width in this case is 9 is our length, and we have 5 up here. So 9 was our length and 5 was our width. And that's going to give us 45 feet squared. All right, so that's the big rectangle, right? The big rectangle. Now let's find the small, narrow rectangle right here. The area for that one, we know that this is 6 feet, and we know that the whole thing here is 3 feet. Now all we have to do is find the width of this part right here. Well, we know this is 5 feet. We know this is 5 feet, and we know this is 3 feet. So if we can take the 5 feet and subtract this 3 feet, then we'll get the width of this. That's going to give us 2 feet down here. So 6 feet by 2 feet, that means length times width. 6 times 2 gives us 12 feet squared. So this is 12 feet squared, and this is 45 feet squared. The whole thing, not just, maybe I should put it out here. We'll put it out here. The whole thing is 45 feet squared. Okay, so what we do is we subtract those two. 45 minus 12 gives us 33 feet. 5 minus 2 is 3, 4 minus 1 is 3. 33 feet squared is the area of this by composing this shape into a larger one and subtracting what we don't need. For our last problem, let's try this one. Ike is building a house in the shape shown below. So in this shape right here. How much total area will the house require on Ike's property? So he's got a limited amount of property here. Let's say that's his property, and he needs to know how much of his property is going to be taken up by this trapezoid, by this polygon, whatever this thing is. All right. So we've got some business going on. Can you see any simpler shapes? And we could go about this two different ways. We could compose these two into a larger shape, and then find the area of this thing and subtract it, and that's possible. Or we could split this up into smaller shapes, decompose it, and do it this way, and then split it up right here. I think that's the route I'm going to go, because that gives me a trapezoid, which is fairly easy, and a rectangle. So what we get is this right here. We've got a trapezoid and a rectangle. We have our two area formulas. The area of the rectangle is fairly easy. We know that this area from here to here, we know that the rectangle itself, this side has 8 feet over here and 32 feet, so that's fairly easy. 8 times 32, and if we want to, we'll just pull that up on the calculator for speed's sake. 8 times 32 is equal to 256 right here, 256 meters squared. And now we need to plug into the trapezoid formula. We've got 1/2 times the height. What is the height of my trapezoid? The height would be this right here. And we know that this side is 16 meters long. We know that on this side, this spot is 8 meters. So all we have to do is subtract 8 from 16, and that gives us 8 meters. So my height is 8. Now, I need the lengths of the two sides. This base right here that is dotted, we know that's the same length as this base down here. So we know that's 32. We're going to add that to the base of the top, which is 12. And then we're going to add those together. So 32 plus 12 is 44. And then we have to multiply that by 8 and by 1/2. So again, we'll pull up our calculator. 44 times 8. 44 times 8 is equal to 352. So I'm going to make a little line here. 352. And then we need to take 1/2 of that, right? We'll multiply that by 1/2. So 352 is our calculator, divided by 2 is 176. So the area of this guy, the whole thing, is going to be 176 plus 256. I've got to add these two together. So 176 plus 256 plus 256 is going to be equal to 432. So 432 meters squared is the area of this whole thing, this rectangle and the trapezoid.